Welcome back to this video tutorial. We can discuss about the properties of matrix multiplication in this video. Okay, for starting the multiplication, we have to consider the properties of this multiplication. That is, you can multiply two matrices if and only if the number of columns in the first matrix equals to the number of rows in the second matrix. What is it? Here we have two matrices, one is A and the another is B with the dimension 2 number of rows for A and 3 number of columns for A. That is 2 rows and 3 columns. And for similarly this B, here we have 3 rows and 2 columns. Then is there any multiplication possible with this A and B? That is A into B is possible. Now we can check this. Here number of columns of A is 3, number of rows of B is again 3. That means these two equals to each other. Number of columns of A equals to the number of rows of B. So A into B is valid here. And what about the product? Here we can represent the product as C matrix, and about its dimension for the product, the number of rows equal to number of rows of our first matrix, and number of column of the product equal to number of columns of our second matrix. That is why it is a 2 by 2 product matrix C. Once more, the resultant matrix C with dimension number of rows equal to number of rows of our first matrix, columns equal to number of columns of our second matrix. So C of 2 by 2. Okay. So consider one example, A and B. We need to multiply these two elements. Now we can consider the first value, product value here. How it possible? We can accumulate the product here by multiplying first row elements of our first matrix with first column element of our second matrix. That is 1 into 1 plus 2 into 4 plus 3 into 7. Okay. So similarly, the second element of our product is obtained by multiplying corresponding elements of our first row of our first matrix elements with second row elements of our second matrix. That is 1 into 5 plus 2 into 2 plus 3 into 1. Okay. Next is about third element of our product matrix, which is obtained by multiplying corresponding elements of our second row of our first matrix with first column of our second matrix. That is 4 into 1 plus 5 into 4 plus 6 into 7. And finally, the last element of our matrix, resultant matrix, is obtained by multiplying the second row of our first matrix with the second column of our second matrix. Okay, 4 into 5 plus 5 into 2 plus 6 into 1. Okay, so this is the multiplication principle. Okay, we need to keep in your mind about the dimension properties and about the multiplication property. Okay, so for coding, for writing the code for this matrix multiplication, we can generate an loops, right? So this is the same given matrix examples, and consider the first multiplication. That means we can now consider the product for the zeroth index location of our product matrix. Okay, so for that we can initialize this particular location with a value 0 first. That is C of 0, 0 is 0. Okay, now we need a loop for accessing this different rows of our product matrix. That is why here it uses a loop with a variable I equal to 0, I less than R1, I plus plus. Why this R1? Because our row dimension of our product matrix matches with the rows dimension of our first matrix. Suppose our matrices with dimension in general R1, C1, R2, C2. Okay, then what about the dimension of the C matrix? This is R1 and this is C2. Okay, row matrix or row dimension of our product matrix matches with row dimension of first matrix, column dimension of second matrix matches with column dimension of our product. Okay, so suppose this is R1 C1 R2 C2, then R1 become that R1 row dimension of C and C2 become the column dimension of C. So for accessing different rows of our product matrix, here it is the loop I from 0 I less than R1. Okay, I value ranging from 0 to 2 minus 1. And similarly, for accessing different columns of our product, here we use another loop for j equal to 0, j less than C2. So this column values ranging from 0 to up to C2 minus 1. Okay, but here we have one more loop. Why we use this third loop? This is actually used for accessing different elements of these rows and this column for multiplication. How it possible? So for that we need to consider the multiplication. 1 into 1. What about the index? Here it is 0, 0 and 0, 0. And next is the partial product obtained by multiplying 2 into 4. What about the indices? Here it is 0, 1. Here it is 1, 0. And for the third partial product, 3 into 7, the indices are 0, 2, 2, 0. From these, here we can see one property for this indices, that is for multiplying two elements, one from the first matrix and second from the second matrix, the column index of the first matrix element matches with the row index of the second matrix element. That is this 2. That is the column index of this 3 matches with the row index of this 7. So we can multiply 3 with 7. Similarly, column index of this 2 matches with the row index of this 4. So 2 and 4. Column index of this 1 matches with the row index of this 1. So 1 into 1. Okay, so how many times we need to repeat? We need to repeat this from 0 to 2, 0 to 2. That is based on this particular dimension. That is either for 0 to C1 minus 1 or 0 to R2 minus 1. Both are valid. Okay, for accessing different elements of our first row of the first matrix and for accessing different elements of our first column of our second matrix, we can use a third loop which is starting from 0 and k less than C1 or k less than R2. Both are valid. And this dimension is based on this C1 or this R2. And this is used for accessing different row elements and different column elements of our input matrices. Right? So, this is the case for obtaining the product of different location of our product matrix, that is C of ij equal to C of ij plus A of ik into B of kj. What is the meaning? From this iteration it will become clear. So first case, C of 0, 0 is initialized with value 0 now. Then I from 0. Is this 0 less than this 2? Exactly true. So come inside. Then initialize j with value 0. Is this 0 less than C2? C2 is again 2. That is less than 2 is true. So comes here. Inside this, here we have the third inner loop when where it is initialized as 0 first. Is this 0 less than C1? C1 is 3 or R2, which is also 3. Okay. So the condition is true again. So come inside and perform C of 0, 0 equal to C of 0, 0 plus A of ik into B of kj. Here all the values are 0, 0, 0. So C of 0, 0 equal to previous sum value of C of 0, 0. That is, here it is the initialized value 0. 0 plus A of 0, 0. That is 1 into B of 0, 0. That is this 1. 1 into 1. So 0 plus 1, 1 get updated here now. Now move to, after completing this for the first time, move here, k become 1. I and j with the same value 0, k now become 1. Is this 1 less than c1? c1 is actually 3. It is again true. So come inside. Then calculate this. C of ij. Ij means C of 0, 0. The same location equal to previous value of C of ij, that is C of 0, 0, which is updated as 1 from this particular iteration. That is 1 plus A of ik into B of kj. A of 0, 1 into B of 1, 0. Okay, A of 0, 1 means this 2 into B of 1, 0 means this 4. 4 into 2. This 4 into 2 is 8. 8 is added with the previous sum value 1. So the new 9 is get updated here. C of 0, 0. Right. So after finishing this, again go here and k become updated by 1, incremented by 1, and k become 2 now. Okay, all I and j kept the same value 0, k become 2 now. Is this 2 greater than 3? No. K less than 3 is a true case. So come again inside this inner for loop body. So we can again C of 0, 0 ij. C of 0, 0 equal to previous 9 value of the C is added with A of ik into B of kj. A of 0, 2 into B of 2, 0. That is 7. 7 into 3, that is 21, is added with previous C value. C of 0, 0 value 9. Okay, 21 into 9, 30 is accumulated here. Now again, after completing this, again go for this. K become 3. Is this 3 less than 3? No, this is a false case. So skip this loop and go here. That is the increment part of our second inner loop. That is this j loop, and j become change from 0 to 1. Is this 1 less than 2? Yes. This j value is less than 2. J equal to 1 and 1 less than 2 is a true case. So we can start the next iteration with I is 0, still I value is 0, but j become 1 now. And we go for here, that is k is initialized 0. Okay, so using this we can start the multiplication of first row of our first matrix with second column of our second matrix. Okay, now the indices, or we are going to calculate the product value for this particular location. That is, initially it is declared as 0. So this C of 0, 0, C of 0, 1, ij 0, 1 is equal to C of 0, 1 plus A of 0, 0 into B of 0, 1. That is A of ik into B of kj. Okay, so 0 plus A of 0, 0 is 1. 1 into 5. Okay, that 5 is added with the previous sum value 0. So 5 get accumulated here. After that, increment this k value by 1 and k become change from 0 to 1. Is this 1 less than 2? Exactly true. So again come inside this. So again modified this C of ij. C of I is 0, j is 1. C of 0, 1 as previous sum value is added with A of 0, 1 into B of 1, 1. That is, this is multiplied with this one and add with previous sum value. That is 5 plus 2 into 2. That is 4 plus 5. 9 is accumulated back here in this location C of 0, 1. Okay, again k incremented. K become 2 now. Okay, is this 2 less than 3? It is again true, so come inside. So C of 0, 1 get updated with previous sum value is added with A of ik into B of kj. That is A of 0, 2 into B of 2, 1. 3 into 1 is added with previous 9 value. That is 12 is now accumulated here. Okay, after that again k incremented, k become 3. Is this 3 less than 3 is true? No, this is not true now. So skip this body. So from here it moved back to this second inner loop, that is the loop with j variable. J incremented and j become now 2. Is this 2 less than C2? No, J is 2 and C2 is already we know that the C2 is 2. So J become equal to C2. So this condition returns a false value. So we need to skip this body again. Okay, and comes here. Here we have no other statement, so directly go here in this part and I increment by 1. I is changed from 0 to 1. Is this 1 less than R1? R1 is 2. 1 less than 2? Exactly true. So we can go for the next iteration. The next iteration is this row with this column. Okay. So consider this row with this column. So for that, initialize this location with value 0 first. Okay, so now I become 1. 1 less than 2 is true. So comes here, initialize again j as 0. And k equal to, sorry, j as 0. 0 less than 3, 0 less than 2 is a valid case. So comes here, k is initialized with 0. 0 less than 3 is true. So comes here, C of 1, 0. C of 1, 0 is updated with previous C of 1, 0 value, that is 0. 0 plus A of ik into B of kj. A of 1, 0 into B of 0, 0. Okay, A of 1, 0 is 4. 4 into B of 0, 0 is 1. 4 into 1. Okay, after that k incremented, k become 1. 1 less than 3 is true. So again here, so the previous accumulated value is 4 in this location. So 4 plus, what is A of ik into B of kj. A of 1, 1 into B of 1, 0. A of 1, 1 is thus 5 into 4. Okay, 5 into 4 is 20. 20 plus previous value 4. 24 is now accumulated back here in this index location of C. Okay, after that again k incremented by 1. K become 2. Is this 2 less than 3? Is again true. So come here. Okay, so the previous 24 is added with A of ik into B of kg. A of ik means A of 1, 2 into B of 2, 0. That is this 6 into 7. 42. Okay, this 42 is added with this previous product value and finally accumulated here. Now this k again incremented and k become 3. Is this 3 less than 3? No, this is not true. So skip this body and comes here. Here we have no other statement to execute. So comes here and j become 1 now. Is this 1 less than 2? Exactly true. So come inside here and initialize the k0 and start this inner loop again. Okay, so now this is the case I equal to 1, j equal to 1 and k start with value 0. Now we can accumulate the result for this particular last index 1 1, I equal to 1, j equal to 1. So C of 1 1 equal to, initially it is, here it is C of 1 1, it is declared as 0. Okay, C of 1 1 plus equal to A of 1 0 into B of 0 1. What is this indicate? This is the shorthand representation of C of 1 1 equal to C of 1 1 plus A of 1 0 into B of 0 1. Okay, so it perform 4 into 5 first. Thus value is accumulated here. Then increment k by 1 and k become 1. So again here we can perform C of 1 1 equal to C of 1 1 into A of ik into B of kg. That is A of 1 1 into B of B of 1 1. B of 1 1. Okay, so it perform this with 2, 5 into 2. That is also accumulated here. So after that increment k and k become 2, 2 less than 3 is true case. So again perform the addition. That is previous product value in or some product sum value in C of 1 1 is added with A of 1 2 into B of 2 1. That is 6 into 1. Okay, so all the values are added, partial product values are added and accumulated here in this location. After that, k incremented, k become 3, 3 less than 3 is not true, so skip this body and go here. And j is incremented from 1 to 2. So 2 less than 2 is a false case, so skip this body. Okay, come here. Come here. Here we have no other statements to execute, so comes here and j again incremented. Sorry, this I again incremented. I become 2. 2 less than 2 is a valid case. No, this is again false. So now we can skip the entire for loops. So finally we have finished our multiplication of these two matrices. Right? So now we can consider the program code for this particular example. Okay, so here we have 3 different matrices A, B and C, initialized with dimension 5, 5, 5, etc. Okay, now with variables R1, C1 for row dimension and column dimension of first matrix, R2, C2 for row and column dimension of second matrix, and looping variables I, J and K. Okay, so first input the row size and column size of our first matrix, second row size and column size of second matrix. So before starting this multiplication, we need to check is the C1 is equal to R2 or not. So check if C1 not equal to R2. If this is not equal, we don't want to perform any multiplication. We can simply display a statement that is matrix multiplication not possible in this case, because the first matrix column dimension is not equal to the second matrix row dimension. Okay, so matrix multiplication is possible. If this condition is not true, that means C1 equal to R2, then in the else part we need to perform this multiplication. Okay, so for multiplying we need to input the number of our first matrix, that is I from 0 to R1, J from 0 to C1. We can read R1 into C1 number of elements and load it into matrix A. Similarly, we can enter the second matrix elements. So the loop vary from I from 0 to R2, J from 0 to C2, and we can read R2 into C2 number of elements from the keyboard and load it into second matrix B. We can simply display these two matrix elements in the matrix form. For this particular loop, which is used for displaying our first matrix element. And this set of loops, these particular statements, from this to this, it is used for displaying our second matrix element in a matrix form. So this is our multiplication part. We have already discussed about this loop. I from 0 I less than r1 I plus plus, and j from 0 j less than c2 j plus plus. Why? Because for the product matrix, the row dimension ranging from 0 to the row dimension of our first matrix, that is r1, and for the column dimension of our product matrix, the dimension ranging from 0 to the column dimension of our second matrix, that is c2. So initialize each and every location of our product matrix first with value 0. And after that we need to access different row elements and column elements for multiplication. So for that we can use one more inner loop, that is here it used with the iterating variable k. K from 0, k less than c1 or k less than r2. Both are valid because the column dimension of our first matrix equals to the row dimension of our second matrix. This is the condition we must we need to satisfy for this multiplication. Okay, so after that, C of ij, each element of our product matrix is updated with previous value of ij with a of I k into b of kj. Different row elements of first matrix multiplied with the corresponding column element of our second matrix, and that partial product is added with the previous sum value of different index location of our product matrix. And finally, we can display our product matrix using the dimension I from 0 to r1, j from 0 to c2. Then we can display this C of ij, C matrix using this I and j values. Right, now we can display this or execute this. Okay, I'm going to input the dimension as 2 rows with 3 columns, first matrix, and second with 3 rows and 2 columns, and the expected resultant matrix with dimension 2 by 2. Okay, now I'm going to enter values of first matrix as how many elements are possible in first matrix? 3 into 2, total 6. Okay, so 1, 2, 3, 4, 5 and 6. Okay, and I'm going to enter the elements of second matrix. Here also how many elements are possible? Total 2 into 3, 6. Again going to enter 4, 5, 6, 1, 2, 3. Okay, now it displays first matrix in matrix form 1, 2, 3, 4, 5, 6. Here the second matrix 4, 5, 6, 1, 2, 3. And the product is like this. So we can, for more clarity, we can put a space here. Okay. Now we can execute once more. Three by 2 matrix, 2 by 3 matrix. 3 rows and 2 columns, 2 rows and 3 columns. The expected result with how many rows? 3 rows and 3 columns. Okay, in first matrix how many elements are possible? 6 elements. 1, 2, 3, 4, 5 and 6. Okay, so enter the second matrix elements, again 6 elements. 1, 2, 3, 4, 5 and 6. Okay, so the first matrix with how many rows? 3 rows and 2 columns. 3 rows and 2 columns. 1, 2, 3, 4, 5, 6. Second matrix with 2 rows and 3 columns. 2 rows and 3 columns. 1, 2, 3, 4, 5, 6. And the product with expected dimension is 3 by 3. So exactly here it is a 3 by 3 matrix, and the product values are 9, 12, 15, 19, 26, 33, 29, 40, 51. Okay, so this is about the matrix multiplication. Okay, thank you.